Hi, I'm Sen Koff. I've just joined Cambridge as also the lecturing team, and I work at the interface of physics and machine learning. I'm a physicist by training, and I use machine learning to do physics, broadly speaking. And for me, this means really to write down equations effectively, and can we get AI to do this in a reliable way? So that's one aspect I work on. The other thing I work on is I like to understand what the neural networks are actually doing. That means what are their dynamics? So what to say, we all know about ChatGPT having millions of parameters, costing lots of money to train. But if we compare this to the human brain, it is rather an inefficient process. Well, in my research, I look at trying to understand these dynamics and try to improve on these dynamics upon understanding those. And so this is actually why it's also very exciting to hear, these opportunities here with Infosys, is because obviously we use all of these neural networks in the real world. So what are the actual challenges that business is facing in terms of the complexity of these networks? Where do we have to make them smaller? Where do we have to make them more efficient? Because these applications tend to drive progress. This we see in physics, in example cases. But we can go beyond having dedicated software for, say, a Large Hadron Collider at CERN, but now apply it also in other domains. So I think these objectives come with the exact business case in mind, or the exact science question we have in mind. And that sets the target. We want to be better than a human, for instance, in doing these tasks. We have a benchmark that we want to beat. We have a target that we want to achieve in terms of training on a small device, for instance. And so that's the variety also makes, us understand, I think, because we can really embrace the whole complexity of it. And I'm quite excited to learn actually whether we have additional complexity that comes in from the business case. Something that we don't see maybe in particle physics or cosmological data that we do work with. There's also, if you talk about applications in this sense, right? If we're talking in particular about generative AI, we standardly do things in terms of, writing models down. Now again, in physics, we want to, develop these to simulate physical systems. But there's another question to the equation is the hardware effectively of this story. And that brings us to obviously thinking about quantum devices potentially and quantum simulations. We all know about quantum computers, but actually how can we make these, integrate into AI potentially.